Picture the biggest bathtub you can imagine, one large enough to hold an entire planet. Now drop Saturn into it. It wouldn't sink, it would float, right on top, rings and all. That sounds like a joke, but it's real physics, and once you understand why, Saturn stops looking like just a big ringed ball and starts looking like something closer to cosmic foam. Start with the numbers. Saturn is enormous, more than 750 times the volume of Earth. You'd expect something that size to be brutally heavy, but size and weight aren't the same thing, and Saturn's average density is actually less than water. Fill a tub, drop the planet in, and unlike Earth, it bobs. The reason comes down to what Saturn is actually made of. Earth is a dense ball of rock and metal, packed tight from the core all the way to the crust. Saturn is almost entirely hydrogen and helium, the two lightest elements in the universe. Even under enormous pressure, those gases don't pack down into anything close to Earth's density. That's the whole trick. Saturn is huge, but it's made of practically nothing. Here's something that surprises most people. Saturn doesn't actually have a surface. Every photo you've seen of that smooth, banded orange globe is just the top of an incredibly deep atmosphere. There's no ground to stand on, no solid shell to hit. Keep descending, and the gas just keeps getting thicker and denser the further down you go, until eventually pressure starts doing strange things to matter itself. Somewhere near the planet's center, that pressure becomes so extreme it crushes hydrogen into a bizarre metallic state, a phase of matter that barely exists anywhere else in the universe and can actually conduct electricity like a metal. That strange metallic hydrogen is a big part of why Saturn generates its own powerful magnetic field, humming away deep inside a planet built almost entirely from gas. But here's the part nobody expects. The rings, the single most famous feature in the solar system, are barely there at all. They look like solid painted bands from Earth, smooth and continuous. Up close, they're nothing of the sort. The rings are made of trillions of individual chunks of ice and rock, ranging from pieces as small as sugar grains to fragments as large as mountains, all orbiting together in a disk that is thinner, relative to its width, than a football field is wide. A spacecraft flying straight through the rings would mostly pass through empty space, threading the gaps between debris rather than crashing through a solid sheet. Saturn moves fast too. A full day on the planet lasts barely 10 hours, one of the shortest days of any planet in the solar system. Spin something that big that quickly and physics leaves a mark. Saturn is measurably flattened at its poles, bulging out at the equator like a slightly squashed ball. What I find genuinely fascinating here isn't just the float trick itself, it's what that trick reveals. Density is really a story about composition, not size, and Saturn is the best proof of that in the entire solar system. A planet can dwarf Earth hundreds of times over in volume and still be, on average, lighter than the water in your bathtub. To be clear, scientists aren't claiming you could actually build an ocean big enough to test this. The bathtub idea is a teaching tool, a fun way to make an abstract number like density feel real, not a literal experiment anyone could run. Still, the physics behind the comparison holds up completely. Take Saturn's actual mass, take its actual volume, and the math says it would float. So next time you see a photo of Saturn, remember, that giant banded planet with the spectacular rings has no solid ground beneath its clouds, no surface to land on, and an average density lower than the water in your kitchen sink. Massive, magnetic, and somehow lighter than it has any right to look. More of these on this channel. Follow along.